So this video is going to go through the 2015 Section B higher level perspective question. So it tells us figure B3 shows the outline plan and elevation of a greenhouse based on the graphic on the right. A pictorial view of the structure is also shown, and then part A tells you draw the given plan and make a perspective drawing of the structure given the following. So first of all, we're told the spectator point is 4.5 meters from corner A. So you can see in our plan there, it's going off at 45 degrees, it's going to be going 4.5 meters. The picture plane is going to be touching off corner A, so right there. The horizon line is 3.25 meters above the ground line, and the door and window are in their closed positions. So they're showing you in the view here, the doors are currently closed and the window as well. Tells us then use auxiliary vanishing points where appropriate. Note it is not necessary to include hidden detail. Part B then tells the door is then hinged open as shown in the pictorial view until it's parallel to the picture plane. So we're going to have to draw in the perspective view when the door is going to be opened. And then part C then, on your perspective drawing, show the roof window when it has been opened through an angle of 70 degrees. So basically when it's opened out an angle of 70. So you can see there, and we're told scale is 1:50. So what I've already done is I've worked out all my measurements here. So I've taken likes of 1.5 meters, which is 1500, and divide that by 50. So you can see there I would have got 30 for that. So the ones I haven't done yet are going to be the spectator point. So 4.5 meters is 4500 mil, divided by 50, that is going to be 90 mil. And then 3.25 is equivalent to 3,250 mil, divided by 50, that gives me 65 mil. And that's all the measurements we need now. So for this question here, I think it's set up in Portrait. It's going to be the best way to solve it on A3. And I'm going to keep my plan up to the top left of the page. So just keep in a bit and then down a slight bit as well. And then for my plan, it's a total of 120 going down, and it is 30 mil spaces in between. And then the width is a total of 90, and then 45 is the halfway point for the roof. And then the window then is half of the 45 that's left. So you're talking 21, 22.5 there. And that's going to be for the window here. So that's our plan, and we're told the picture plane is touching off corner A, and our spectator is going off at 45 degrees, and the horizon line is at the horizon line. The spectator is 90 mil away there. So that's our spectator. So the first thing we're going to do is we're going to get our picture plane. So as always, we join our spectator to the furthest point off to the left, the furthest point off to the right, and then we're going to bisect that angle that's in between. We join the spectator through that point there. Our bisector, and then we use sliding set squares then to get the right angle to that. So our picture plane is going to be this line here. So that there is our picture plane. To get our vanishing points, we go parallel to our sides from our spectator. That gives us our VP1 there, where we'll be taking the horizon line, and then going parallel up this way, give us our VP2, which will be where it hits the picture plane there. From there then, as always, I'm going to pause the video, I'm going to turn the page around so we can have our picture plane parallel with our T-square to make it easier to draw. Now that's set up there, I'm ready to start drawing in my ground line and my horizon line. So basically I now have my T-square parallel with the picture plane. So I'm going to set my ground line around about here because I'm fairly tight with space in terms of what the camera can actually take in. So the ground line there, as you see, is parallel to the picture plane, and it is also the horizon line. If I look at the question again, it's 65 mil above the ground line. So 65 mil up there, and there's my horizon line. My vanishing points then, I want to take them down, and there's my actual vanishing point 1 and vanishing point 2 then on the horizon line. They're the points I'm going to be joining back then to when I'm drawing the perspective. So now we're ready to actually start doing it. So first thing I'm going to do is get the outline of the shed. So corner A is touching the picture plane, so I can take that straight down, and that gives me this point on the ground here, so that basically is corner A. And that, you can see, disappears off to the left and also disappears off to the right. That there, and there. Now, every other corner then is going to go back to the spectator, and where it hits the picture plane is going to be taken straight down. That's what's going to give us our perspective view, how it gets narrower. So the first thing I'm going to do is take my black corner here, where you see, join the spectator, hits the picture plane there, and now what I have is that side of the shed. I know it's going back as far as that distance there. For the height of the shed, we're told in the elevation up to where the roof is, it's 45 mil. So this height, this height, this height, and this height, they're all 45. But the only true height I can take is from corner A, which touches the picture plane. So 45 mil up, and that goes back to VP1, and I can join it back to VP2 as well. And what I now have is, I have the height of the wall on this side. Going off to the left, just to have the open area there before I have the slope of the roof, I can see that this corner here joins back to the spectator, hits the picture plane here, and that's now giving me this width. The next part then, I'm going to get these individual parts to make up the glass pane, so you can see just here in the question these lines there. So the first thing I'll do is join them back to the spectator. I'm going to take the picture plane once again, they go straight down, and that gives me that vertical line there. Join this one back, that gives me this vertical line here. And the last one along it joins back, and that gives me that one there. Next part then is going to be getting the door in position. So I'm just going to draw it in its over as if the door is closed first. So the door is going to be slightly to the right. Yeah, it's not on the centre exactly, so it's going to be going 30, 30, 30. So if I mark it off my plan, the right side of the door is going to be there, and the left side of the door is going to be there. So for those 2 points, I join them back to the spectator, and where they hit the picture plane, they go down. And the height of the door, when it's open, we can see in the question, it goes up to where the slope of the roof actually is. So I have to get that much first. So I have my 2 lines now here. To determine the height, I need to now get my slope of my roof, which I'm told is 35 degrees. So I need to use an auxiliary vanishing point for this. So the first thing to determine is where the slope is occurring. So this set square here, imagine like it was at 35 degrees. I know it's 30. But for example, this side of the roof here, that would be that slope there. It'd be sloping up this way. And this side here, be sloping this way. So slope isn't occurring on this side or this side. It's occurring along this side here. So the first thing as always, it's like the spectator standing, looking off in the distance at 35 degrees. And where the horizon line is, so the picture plane for us here, we're going to take that vertical height up. So we're going to go perpendicular to that. So what I need is my tractor. And I'm going to set it to 35 degrees. So remember, I'm using my vanishing point on this side here because the slope is occurring on that surface there. So there's my 35 degrees, and to get a height, we always measure vertically straight off the ground. That's our ground there, the spectator standing here. That's the ground all the way across to horizon there in the distance. And that vertical distance there will give me this height. So I'm going to mark that in red. So that height there is the one that I want. Now the roof is going to be sloping upwards there and upwards there. So what I'm going to do is I'm going to take that and have it going below my vanishing point. That distance that I have here, to go below it. So you can't see it there. I have it marked below here. And what I'm going to do then is I'm going to take that then and take it up for the roof then. So for here, I join them back. You just can't see it with the camera, and that gives me that slope for the roof there. Now where it stops along this line here. So what I can do is I can join that point back to S and take it straight down, and it meets there. And that's what gives me that point. And I can join that back to there. And then that's going to join back to VP2. And then this other end of the roof here can join back to S. And where it hits up down there, where it hits that point there, and I have the slope of my roof here as well. And I have that part of the roof drawn there. What I can also do is, if I want, I could take that same distance, swing it both. And you'll see I'm going to get the exact same result here. If I was to join this point back to here, you can see it's the same thing. And what I can do then is I can use that vanishing point, the auxiliary one, to get these lines on the roof here instead of having to take them down each time. And then for the door then, you can see the door in the open position is where that line goes up and hits the roof each side. You can see if I was to join them back, they would join back to VP1 there. And that would be the door then, drawn in in the open position, or sorry, in the closed position. That's what the door will be. And that will complete up to part A. So what I'll do is I'm going to record a separate video for parts B and C, because I have another class to go to now, so I'll have that uploaded afterwards then.